And myself Anil Dobrial. Student, today we will do chapter number 1, relation and functions. And relation and functions, some terms we discussed in our previous chapter, inverse trigonometric functions. Now what is a relation? A relation is a subset of A cross A. We also written it as R is equal to AB belongs to A cross A related to B. So we discussed all the terms in our previous chapter, so you can check. Now types of relation. First type of relation is reflexive relation. A relation are defined on A. Set A is said to be reflexive if A belongs to R for all A belongs to R, or A related to A for all A belongs to A. So this definition is also given in NCERT book, you can check. Second relation is symmetric relation. A relation are defined on A. Set A is said to be symmetric if A1 A2 belongs to R, such that A2 A1 also belongs to R for all A1 A2 belongs to A. So if this condition is existing, then that relation will be symmetric relation. Now transitive relation. Transitive relation. A relation are defined on a set A is said to be transitive if A1 A2 belongs to R and A2 A3 belongs to R, such that A1 A3 also belongs to R for all A1 A2 A3 belongs to A. In this case, that relation will be transitive relation. We have to understand what is the equivalence relation. A relation R is defined on a set A is said to be an equivalence relation if R is reflexive, symmetric and transitive. If any relation is following all the three relations, then it will become a equivalence relation. Now what is a function? Let x and y be two non-empty sets. A function or mapping f from x into y written as f such that x belongs to y is a rule by which each element x belongs to x is associated to a unique element x belongs to y. This is a function. Graph of a real function f consists of points where coordinates xy satisfy y equal to fx for all x belongs to domain f. So linear graph or quadratic graph, cubic graphs, that all are also the graph of function. Now constant function. If k is a fixed real number, then a function fx is equal to k for all x belongs to R is called a constant function. Now student, identity function. The function that associates each real number to itself is called an identity function and is usually denoted by I. Now types of function, it is very important. First type is one-one function or injective and many-one function. So if fxy is said to be a one-one function if image of distinct element of x under the predistinct, thus f is one-one if fx1 is equal to fx2. If x1 is equal to x2 for all x1 x2 belongs to x is satisfying, then f is a one-one function in that case. And if x1 is not belongs to x2, such that fx1 not belongs to fx2 for all x1 x2 belongs to x, a function which is not one-one also known as many-one function. So we have taken an example of this. Find whether the following functions are one-one or not. So first function f such that r related to r given by fx is equal to x cube plus 2 for all x belongs to r, and second f such that z belongs to z related to z given by fx is equal to x square plus 1 for all x belongs to z. Now we will solve this example. First example, let xy be two arbitrary element or r domain of f such that fx is equal to fi. So fx is equal to fi, so we can write x cube plus 2 is equal to y cube plus 2. So 2 will be cancelled out, x cube is equal to y cube, and if x cube is equal to y cube, then it will implies x is equal to y. Hence f is a one-one function from R to itself. Now second equation we have f such that z related to z given by fx is equal to x square plus 1 for all x belongs to z. Now fx is equal to x square plus 1 we have, so we will put some values. F1 is equal to, we are finding, so it is coming 2. F minus 1 we are finding, it is also coming 2. So f1 is equal to f minus 1 is equal to 2, but 1 is not equal to minus 1. So f is not 1 1 because for 1 1 function there this value of x should be different every time. Now second function is onto function or surjective and into function. A function f such that x related to y is said to be an onto function if every element of y is image of some element of set x under f. For every y belongs to y, there exists x in x such that fx is equal to y. In other words, a function is called an onto function if its range is equal to codomain. Now a function f such that x related to y is said to be into function if there exists at least one element in y which do not have any pre-image in x, or we can say if f is not onto then it will into function. Example we are taking, so that function f such that n related to n given by f1 is equal to f2 is equal to 1 and fx is equal to x minus 1 for every x greater than 2 is onto but not 1 1. So we are solving it. F is not 1 1 as f1 is equal to f2 is equal to 1 but 1 is not equal to 2, but f is onto as given any y belongs to n. We can choose x as y plus 1, so such that f y plus 1 is equal to y plus 1 minus 1. So 1 will be cancelled out, y will come. Also 1 belongs to n, we have f1 is equal to 1. Third function we have bijective. Bijective function, a function f such that x belongs to y is said to be a bijective function if it is both 1 1 and onto. Example, so that function f such that r are related by fx equal to 3x square plus 5 for all x belongs to r is a bijective. So we observe the following properties. If it is satisfying, then it will be a bijective. Now first of all we are finding injective property. Let xy be any two elements of our domain. So fx equal to phi, it should be so x cube plus 5 is equal to 3y cube plus 5. 5 will be cancelled out. 3x cube is equal to 3y cube, x is equal to y will come. Thus fx is equal to fi. So we can say x is equal to y for all xy belongs to r. So f is an injective. Surjective property we are checking. Let y be any arbitrary element of r codomain, then fx is equal to y, 3x square, sorry it should be 3x cube. 3x cube plus 5 is equal to y. X cube is equal to y minus 5 upon 3. So x is equal to y minus 5 upon 3 whole power 1 upon 3. Thus we find that for all y belongs to r codomain, there exists x is equal to y minus 5 upon 3 whole power 1 upon 3 belongs to r domain, such that fx is equal to f y minus 5 upon 3 whole power 1 upon 3. So 3 y minus 5 upon 3 whole power 1 upon 3 whole power 3. So 3 will be cancelled out, 3 will be cancelled out here. So it will be y minus 5 plus 5 is equal to y will come. So fx is equal to y we obtained. This shows that every element in the codomain has its pre-image in domain. So it is clearly observed that f is surjective and hence f is bijective. So we discuss properties of relation function today. Thank you very much.